So how do you teach a machine to think? It's a huge question, right? One of the biggest challenges of our time. And you might think the answer is all about code and complex circuits. But what if I told you the real secret is looking in a mirror? Because to build an artificial mind, we first had to get a handle on our own. This is the story of that reflection and how it changed, well, everything.
You know, this fundamental question, it's not just for programmers. It's really about deconstructing what thinking even is. And what's wild is that computer scientists and cognitive psychologists, they were basically climbing the same mountain, just from different sides, both trying to get to the top to understand intelligence. And the answer they found is that to build an artificial mind, you kind of have to understand a real one first. The whole history of AI and cognitive psychology is this incredible back and forth, this feedback loop, where each one pushes the other to do things they never thought possible. So let's start at the beginning. Our journey kicks off with what I like to call the cognitive spark, the moment we started turning our theories about the human mind into actual blueprints for the first digital models of thought. Believe it or not, the core questions behind AI are, well, they're ancient. I mean, we're talking ancient Greece, with Plato and Aristotle going back and forth on whether we're born with knowledge or learn it all from experience. Fast forward to the 17th century, you've got Descartes trying to separate the mind from the body. But the real game changer, that came in the mid-20th century. Thinkers like Noam Chomsky came along and said, hold on a second. He argued that something as complex as language couldn't just be learned. There had to be something built in, a kind of mental software. And that idea of mental software, man, it got a massive boost from the world of computer science. See this diagram? It's a Turing machine. Alan Turing's idea here wasn't just a blueprint for a computer. It became this incredibly powerful new way to think about the human mind itself. The idea was that maybe thinking could be broken down into simple steps: reading, writing, moving symbols around, just like this theoretical machine. And all of a sudden, the brain wasn't this mysterious black box anymore. It was an information processor. This led to a huge shift. And the AI pioneers, guys like Herbert Simon and Alan Newell, they took this metaphor and they just ran with it. They didn't just see the brain as inspiration. They truly believed they could copy its functions. As they boldly put it, machines could actually think. And they didn't just talk the talk. They built things, like the General Problem Solver, or GPS. Now, this program was totally revolutionary. Why? Because it wasn't about crunching numbers. It was a direct attempt to simulate human reasoning strategies, like figuring out the steps to get from where you are to where you want to be. It was one of the first times AI researchers were literally looking in that cognitive mirror and building exactly what they saw.
But here's the really cool part. That mirror reflects both ways. These digital models of the mind didn't just help us build smarter machines. They turned into these amazing new tools for psychologists, letting them test out theories about the human brain in ways they could only dream of before. A perfect example of this is the artificial neural network. I mean, it's a computer model that's directly inspired by the brain's own messy, complicated web of neurons. By building and testing these digital networks, researchers could suddenly run simulations of super complex human stuff, like how we lock in memories while we sleep, or how we make those split-second gut decisions when the pressure's on. And this visual just nails how it all connects. You start with these simple models of how neurons talk to each other. Those build up into neural networks, which let us model how we think. That then powers all these complex AI applications we see today. And get this, it even loops back to inform real-world treatments like cognitive therapy. It's like a ladder of understanding, and we're building it one computational step at a time. Okay, so that's the history. But what does all this mean for us, right here, right now? Well, this collaboration that's been going on for decades isn't just some academic exercise. It's having a huge, tangible impact on our daily lives. Seriously, this partnership is reshaping everything. Think about education. We've got AI tutors now that can adapt to how a student learns, just like a great human teacher would. Or the workplace. Machine learning is optimizing everything from shipping routes to project deadlines by predicting problems before they happen, kind of like how our brains do. And in healthcare, AI is helping doctors spot cognitive disorders in brain scans way earlier and with more accuracy than ever before. This stuff is truly everywhere. Let's zoom in on a really powerful example: cognitive rehabilitation. We're talking about technologies like brain stimulation, which are guided by these super precise computer models of the brain. They're helping patients recover from strokes or manage conditions like ADHD. We are literally using artificial models of the mind to help heal the real thing. It's just incredible. But, of course, with technology this powerful,
It's not all smooth sailing. It comes with some big challenges. As we keep pushing forward, we have to navigate a whole new and very complex ethical horizon.
Right. So this whole collaboration forces us to ask some really profound questions. When an AI system makes a critical decision, who's responsible? As these systems learn and change on their own, how do we make sure their values line up with ours? As this image suggests, these are the deep, tangled roots of the ethical problems we're facing now.
And those roots branch out into some very specific, very real concerns. We're talking about the privacy of our cognitive data, literally the patterns of our thoughts. There are risks of inequality. What happens if these cognitive enhancement technologies are only available to the wealthy? And then there are fundamental questions about our own autonomy. Look, setting up strong rules and frameworks to handle this stuff isn't just a nice to have. It's absolutely essential.
Which leaves us with this, the big final question. As we succeed in building machines that mirror our own cognitive processes, we also create a new kind of accountability. So who's responsible for the thoughts of a machine we taught to think like us? It's a question we're all going to have to answer together.